Hello and thanks for watching Best Maths Tutors. I'm continuing to go through the Edexcel A-level paper from 2018, and this is paper 1, and we're on question 2. So question 2 is a calculus question, and we're told that a curve has got this equation, y equals x squared minus 2x minus 24 root x. And first thing we've got to do is differentiate it, so we've got to find dy dx. And in order to do that, what we're going to need to do is we're going to need to write this in index notation, which means taking this root, and instead of having a square root sign, we need to put it as a power. So since we know that root x is actually equal to x to the power half, well, that's something we need to know at A level. We can write the root is the bottom number of the fraction. So since this is a square root, then this becomes x to the power half. So we're going to rewrite this, and we're going to say, so part A1, we're going to say that y is equal to x squared minus 2x minus 24, and it's x to the half. And what we need to do is we need to differentiate that, and we're going to use the general rule that if y is equal to a x to the power n, then if we differentiate that, then we will get that the n will multiply to the front. We'll get n times a. I should say a is a constant, n is also a constant, which means they're both numbers in this case, and x is the variable. And so what we then do is we subtract 1 from whatever the value of n is, so whatever the power is. So we do that to this one, the first part of the expression or equation. We should say that the 2 will multiply to the front, so we'll get 2x, and if we subtract 1 from the 2, it now becomes x to 1, which we don't need to write the 1 there. This will mean that the x has got a power 1 on it, and if we subtract 1 away from that, we get 0. So effectively, that just means the x disappears, and we're left with constant in front, so that's the 2. In this case, what we're going to do is we're going to multiply by the half, so we're going to have half times the 24 at the front, and we're also going to subtract 1 from half, and if we do that, we get a negative number, so we're going to get minus half. So just tidy that up a little bit, so we'll get 2x minus 2, and then minus 12x to the minus a half. So that's part 1 done, A1. And then the second bit is just saying differentiators again. So this is finding the second differential. So that means whatever we got for dy dx, we're just going to differentiate again. So if we do that, then we're going to get d2y dx squared. So that's just the notation for saying we've differentiated it a second time. So if we do that, we've got a constant multiplying x to the power 1, which we don't usually write the 1, but that's what it is there. So this bit disappears, so we're just left with 2. And then a constant also disappears, so that will go. And then we have to multiply to the front, so we're doing here, we're going to differentiate this bit now. We're going to multiply the power of minus half to the front, so we've got minus the 12 times minus a half times by x, and now we subtract 1 again from this minus half, and we actually get minus 3 over 2. And so that's going to give us 2, and then minus 12 times a half is minus half, is going to give us plus 6 x to the minus 3 over 2. So that's the second part done, part 2. So now if we're on B, we've got to verify that this curve has got a stationary point when x equals 4. Well, stationary points, we have stationary points when dy dx equals 0. So because we've got our, I'll just write this again, dy dx equals the 2x minus 2 minus the 12x to the minus a half. If we were to substitute in x equals 4 into this and get 0, we'd know we've got a stationary point. And a stationary point actually means a maximum or minimum. So if we have a curve like this, let's say, then stationary points is either this point here or this point here. They're points where maximums or minimums. So for x equals 4, then what that will give us is that dy dx is equal to 2 times 4 minus 2. So 4 is what I'm substituting in there. And then minus 12. And then this is going to be 4 to the minus a half. So again, I'm substituting in the 4 there. And so what that will give me is 8 minus 2. And so then what we have is a minus half means it's actually, the minus means it's in the denominator. We're actually finding the square root of 4. So I'll just move this over a little bit, just make a bit of space so we can actually see what we're doing a bit clearer. So we've got that dy dx is equal to 8 minus 2, and then the square root of 4 being square root of 4 here being 2, we've got minus 12 over 2, and if we work that out, we've got 8 minus 2 and then minus 6, and we can see that does indeed give us 0, which is what we needed to show. So we'd need to probably make the sentence that hence is a stationary point, just to show that we know what we're doing there, just to show that we know that the fact that dy dx is equal to 0 means that we're at a stationary point. And next thing we've got to do is determine the nature of this stationary point. And what that would mean is there's two possibilities. We need to know whether we've got a maximum, which looks like this, so we've got like a peak of a graph at that point, or we've got a minimum. So we can imagine on our curve we could rise to a maximum point, or we could go down to a minimum. This is a maximum, this is a minimum. And for our second differential, that's what will tell us which is which. If d2y by dx squared is actually less than 0, what we've got is we've got a maximum. And if d2y by dx squared is greater than 0, we've got a minimum. That seems slightly counterintuitive in that you sort of think of maximum as being a big number, but in the case of the second differential, it's negative if we have got a maximum. And that's because what happens is the gradient is actually decreasing at a maximum. We can see that there on this side it's a positive gradient, on this side it's a negative gradient if we was to take a tangent, and at the maximum the gradient is 0. So the gradient has actually decreased as we've gone past the maximum there, which is why it's less than 0. And the opposite case when we're going through a minimum, we've gone from a negative gradient to 0 to a positive gradient, and hence that's why the d2y by dx squared is greater than 0 at a minimum. So what we need to do then is at x equals 0, we need to look at what, sorry, not x equals 0, at x equals 4, we need to determine the nature of the stationary point. So what we're going to do is substitute it into this expression for d2y by dx squared. So at x equals 4, we get d2y by dx squared is equal to 2 plus 6 times, and then this is 4 to the power negative 3 over 2. And it's it's not always necessary to work out the exact answer for this. We can see that all parts of this are positive because the 2 is obviously positive, and the this power of 4 is also going to be positive. So overall, this is going to be positive. So this is greater than 0. And so, but I will work it out anyway, but we could see it's greater than 0, so we do know it's a minimum. So we've got 2 plus 6, and then this is, because it's the negative, 4 to the 3 over 2. So we can square root 4 to get 2 on the bottom of there, and then cube it. So we can say if we, so let me just write that, 2 plus 6 over 2 cubed, and so that's going to be 2 plus 6 over 8. So that's going to be 2 3/4. So we can see that is positive. So since d2y by dx squared is greater than 0, we have a minimum. So I hope that's been helpful to you. If it has, please like our video and subscribe to our channel by clicking the button at the bottom. And also visit our website, which is bestmathstutors.co.uk. Thanks for watching.